Today, we will be presenting the topic technique of differentiation. Differentiation is one of the key concepts in the calculus. Basically, it is the process of finding how fast a function is changing, or the slope of a curve at any point. In mathematics, differentiation helps us understand how quantity change over time, like speed, velocity, or growth. There are also several techniques of differentiation that we use depending on the structure of the function. These include the product rule, the quotient rule, the chain rule, implicit differentiation, and other basic rules such as power rule, exponential, logarithm, and trigonometric derivative. So, in this presentation, we will apply this technique to solve a given problem. Alright, for this question, we are finding the derivative of y equal to tan 5x plus ln 2x minus 1 squared. We are using the tap-away technique. So basically, think of the whole function as a bunch tap-away containing stacks inside each other. So our job, open them one by one and differentiate every layer like we are unboxing Raya's cookies. So imagine tan is the big tap-away. You open it, inside got 5x. Differentiate the outside first. Tan becomes secant square. Then open the inner container. The derivative of 5x is 5. So together you get 5 secant square 5x. Basically, open, differentiate, open, differentiate. Now, this one is like tap-away, inside tap-away, inside tap-away. The first layer, the outside is ln. The second is, inside ln is something square. The third layer is, inside the square is 2x minus 1. So, we open one by one. So, ln become 1 over 2x minus 1. So basically 1 over something inside it. Second one, the square become 2x and 1 over 2x minus 1. Lastly, 2x minus 1, we derivative it become 2. Now, we multiply all the layer together. And so it become 4 over 2x minus 1. Now for the part B. The function is y equal to 3x minus 1 squared over x plus 2 power of 4. So this is a fraction. So we use the quotient rule. The quotient rule says derivative equal to u prime v minus u v prime over v squared. So here you can find u equal to 3x minus 1 to the power of 2 and the v in the bracket x plus 2 to the power of 4. First, we must differentiate using the chain rule for the u. So it become u prime equal to 6 in the bracket 3x minus 1. And for the v become v prime equal to 4 in the bracket x plus 2 to the power 3. So after you differentiate, you will substitute in the chain rule formula. Y prime equal to u prime v minus u v prime over u squared. So you bring it into the formula. It becomes 6 in the bracket 3x minus 1 x plus 4 the power of 4 minus in the bracket 3x minus 1 square times 4 in the bracket x plus 2 to the power of 3 over x plus 2 4 square. After simplifying, we can factor and reduce the expression. So this gives us the final answer, which means 3x minus 1 minus 6x plus 16 over x plus 2 the power of 5. So that's how we differentiate both functions. The key idea is use the chain rule for the part A and use the quotient rule for the part B. Once you know which rule to apply, the process becomes much easier. That's all for my explanation. Thanks for listening.
For the question 3, we're going to separate the term given. So we will solve one by one. First term, we need use product rule. For u and v, we get from term given. So we're going to differentiate to get u prime and v prime. So we need to sub into the formula. And then we're going to get 2xy plus x squared dy over dx. And then for the second term, we're going to proceed with exponential rule. From the rule, we're going to use Tupperware method. So we get 3 exponent power of 3x. Third term, there is negative signs y. So we need to convert to negative cos by using trigonometric rule. Also, don't forget to put dy over dx. Okay, why we should put dy dx? It's because there is y in the term. So, for the next step, we're gonna differentiate for x squared. So, we get 8x. And when we differentiate 10, we will get 0. And lastly, we will combine all the steps to make one equation. So it's gonna be our last answer. And then we need to put all the terms that have dy dx in the left side. And then another term we put in the right side. And then we need to leave only dy dx at the left side. So for the x squared minus cos y, we need to bring the other side. So for our last answer, it's going to be dy over dx equals to 8x minus 2xy minus 3 exponent power of 3x divide the 2 x squared minus cos y. Thank you.
Now, let's put proof to the question 4, which is to estimate the value of square root 2.99 plus 1 plus 2.99 squared by using linear approximation. The first thing is you guys should know the linear approximation formula, which is f x naught plus theta x equal to f x naught plus f prime x naught times 2 theta x, where x naught is the product of x minus x naught, and then x is the given value from the equation, and then x naught is the chosen value that we change into a whole number. So we go through to the solve it step by step. So the first step is we should find x that given from the equation, which is 2.99. And then the second step is find x naught, where x naught is the chosen value that close to x. So we take x naught equal to 3. The next step is find f prime x by using differentiate. So we define the function first as fx equal to square root x plus 1 plus x squared. This can also be written as x plus 1 power of 1 over 2 plus x squared. Now we can differentiate the function. How to differentiate is the power of the fx that we got need to move forward and the power also must minus 1. So it will be f prime x equal to 1 over 2 x plus 1 power of negative 1 over 2 plus 2x. So the last one, we can substitute the values into the formula. So we need to replace x naught to 3 and the data x is the product of x minus x naught, which is 2.99 minus 3, so we got negative 0.01. So the final answer is gonna be 10.938.
Alright, so that brings us to the end of our presentation. From this project, we basically review the foundation of differential, what it means, why we use it, and the technique that help us find derivative efficiently. After that, we apply those techniques to different types of functions, including trigonometric, logarithm, rational, and even equations that require implicit differential. We also explore how linear approximation can be used to estimate value without a calculator, which show how differentiation isn't just a theory, but something practical that helps us simplify real mathematical problems. Overall, this assignment really helped us strengthen our understanding of calculus, especially in recognizing which method to use for each type of function. Hopefully, our explanation made everything clear and easier to follow. Thank you for watching, and we hope this presentation has been helpful. Thank you.
Alright, for the reference, the information I use in this presentation is based on the explanation and lecturer notes provided by Madam Ashura Abdul Nasir during our class session.